Thank you for inviting me, Gisella, and thank you for your sweet words. And yes, my story here in Politecnico, I was sitting there a few years ago, and thanks to Gisella, I had a strong passion for light. And since I graduated here in interior design with my thesis with her and Professor Gianni Forcolini, very famous and well known for lighting design books and manuals. Since then, my professional career was and is still in lighting. First, with a company very well known for technical lighting fixtures, a company from Austria. First, I have been working as a lighting designer in Milan in their professional office. Then I moved in Austria in the Vorarlberg region when this company have the headquarters, and I was developing lighting design projects in international projects department, so designing projects with applications all around the world. Then I remembered, because Gisella always tells me that I am a designer, and so to never lose creativity. Then I remembered then, and I moved to an Italian company when I had the chance. That is Floss. Do you know Floss company? Yes, I see a smile and another one. Good. And I can introduce just a bit of the history of this company. Just a few pictures. Probably you know a bit of the history of this company. It was founded by Mr. Gandini, you see in the first picture, with the Snoopy luminaire designed by the architect Castiglioni. And there you see the architect Castiglioni as well. And in the lower corner, left side, you see Mr. Piero Gandini, that is now the CEO of the company. He is the son of the founder. And the company was born in Merano, in Italy, and at first it was just an association of designers that came together because they wanted to build their own ideas. You see, for instance, the first cocoon luminaire, the Taraxacum, the first version. And this was just how the company was born. But, you see, is very well known for decorative lighting fixtures since 10 years or so. You see here in the 62 is the founding year in Merano. And then Floss started to develop also contract projects, so with a strong focus also on the professional part, with more technical luminaires. And with buying the new company, Ares, that is a company who builds outdoor luminaires, also moved the focus on outdoor as well. So what Floss does today is to develop projects in every part of the architecture, indoor, professional and outdoor, and is present all around the world, of course. A few numbers for plants, 600 employees, and so on. Talking about projects and areas, You see, the first area is, of course, residential, because one of the first aims of the luminaires designed for Flos was decorative, so perfect for residential and hotels and so on. You see hotels as well with our decorative luminaires, but in the recent years also a bit professional focus also on all the technical part for shops and retail, for instance, offices, but very focused also on design and creativity and art. So I was very quick on this because this is not a company presentation. And the focus of this presentation will be light for art. As I told you before, Flos is very well known for their decorative elements. This is one of the most famous, probably the most one. That is the Arco Luminaire designed by architect Castiglioni. And a lot of the designers that work for us designing luminaires. But as I told you before, now we have a very strong focus also on the technical part, and this is where Light for Art came across. Not only in designing luminaires, but also in choosing components. You see an LED here. And in this family of products, it's very important to push the technological part to the limit. And it is why we print a paper catalog, and in a few weeks it's old and put in the trash because it's technology, so it's nature. And Light for Art. So I will have just a quick overview of the technology and then a few guidelines, and then a case study that is probably important for you to look, just to understand how to approach lighting of a masterpiece, a piece of art, a painting, and so on. Do you know what the LEDs are? Yes, and how they work. So this is the basics, the principle. You see in the corner the symbol that we use to define an LED. An LED is a semiconductor, so an electronic component that emits light when current is passing through. We used to say that the LED is doped because when it's doped, we create holes in the p-type, and we have electrons in the n-type, negative. And when current is passing through, is emitting light. So just to keep it simple. You see a bit of history regarding LEDs. In the 50s, 1955, Braunstein is discovering infrared LEDs, so LEDs that are emitting light only in the infrared frequencies. Then in the 62, they discover LED invisible light. But the most important discovery for the LED technology and for modern lighting fixtures today is in the early 90s, so 1993, by Nakamura, that is discovering the LED that emits light in the blue spectrum. And this is the father of the LED that we use today. So every LED is blue at first, then the manufacturer puts a phosphor cover to transform the light from the blue emission to the white one. So it depends how many phosphor are you putting on the blue LED, and this is changing what you are obtaining in the end. So a warmer light or a colder light. And you see here a diagram that is very important for us, because you see in yellow a curve that shows you the light emission of a common halogen light source that comes across all the diagram, all the frequencies, also UV and IR. You see an LED, blue, green or red for instance, has a peak only in the visible spectrum, and that means that it's not emitting anything at all in UV and IR. And this is very important for us because for conservation and respect for the paintings, you have UV and IR that are very dangerous in terms of frequency. So, for instance, with halogen lamps, you used to apply additional filters just to exclude these parts of the frequencies. UV, for instance, is dangerous because of discoloration, and IR frequencies are dangerous for drying and cracks, for instance. And what is commonly used for lighting a painting? Usually projectors, and the optics are very important because think about the dimensions of a painting. You have, of course, a variety of dimensions, proportions, angles, and so on. And so, choosing the right light distribution, you see a cone diagram that tells you basically the angle, so the aperture of light, and the lux levels you have at each distance. So, for instance, 50 centimeters, 1 meter, and so on. Today, two concepts are used for optics in lighting: lenses. The first one, you see, are very compact, and you have the refraction of the lighting flux inside the lens itself. Because of these lenses are so small, they can be used for very tiny spotlights. For instance, the first one is a very, very compact spot that is 50 millimeters long, so 5 centimeters. The second technique that is used for optics in building projectors for us are reflectors. That is a bit a traditional technique. A reflector usually is in aluminum or crystal, and is used just to direct the light flux in one direction. And so is no more a refraction inside the material, it's just a reflection like on a mirror. You see, the second luminaire is a bit bigger because usually these reflectors need a bit more space. Using this diagram, you see an example of a trap with different spotlights, from the narrowest one to the wider ones. You try to mix them both, so narrows and wide ones, just to have uniformity on paintings or accent lighting on sculptures and so on. So we talked about optics, and now another very important characteristic of lighting for museums and art is the binning. So binning is a selection. So how many times do you see different luminaires, different LEDs that on the data sheet, on the PDF or on the paper, they emit exactly the same lights, so the same kelvins and everything, but when you put them pointed on a white wall, they seem a bit different. So this is absolutely not good for lighting a piece of art. And so the binning is one of the most important features that you have to look at when choosing a luminaire for art. For instance, you have this selection based on color temperature in kelvins, 3000 kelvins, 4000 and so on, and also on brightness. So the more accurate is this process, the more the luminaires are exactly the same, and so the piece of art can be lit in the best way possible. This is probably a bit too technical, but it's the same concept referred to a specific diagram. Okay, so it's just how far the point is from the line that defines the difference between one LED and the other, one luminaire and the other. But just try to keep it simple, and this is an example, an installation that we did with Flos Luminaires in Milan, in Palazzo Reale, with this exhibition of Bernardo Luini paintings. That is the projector that my colleagues were using while lighting this exhibition, and you see that you have a few values. That values are defining the CRI or color rendering index, and this is the second parameter that is very important on lighting art, and it defines how well the light source can show the colors for what they really are. Okay, so we have 8 test colors, and the match of the light source with this 8 test color is defining an average. That is the first number that you see there, for instance 94, that is telling you the more higher is this number, the more the light source, LEDs or not, is showing colors for what they really are. Then you have a few exceptions, because the average is calculated on the first 8 numbers. The other ones, from the 9th to the 14th, are, how can I say, optionals, okay? Then you see, for instance, one of the most difficult frequency for high color rendering luminaires is red. For instance, one of the manufacturer that defines a very high color rendering on red is the Xicata company. And so you can choose first a very high color rendering index. Basically 70 is low, 80 is in the average, and from 90 and up are very high and good for lighting art paintings. But another thing, you can choose the features of the light source to match a specific color in the painting. So for instance, you have a Van Gogh luminaire that is with a lot of blue colors, and you think that the most important part of the painting to lit is the blue, of course. You probably have to choose an LED that is very high in the blue frequency, so very high quality in lighting this frequency in particular. Then one of the most important aspects when lighting up a a piece of art is the conservation, the respect for the painting. And we have regulations in Europe that defines how many light can reach the piece of art during a day. Usually you find this in that regulation, UNI EN 12464.1, and you see that for exhibits insensitive to light and exhibits sensitive to light, there is not an average value, because this is just up to the designer to decide where is the limit, because it depends on the material. So for instance, I wrote this in red. Textiles and very old oil paintings can support 50 lux average, for instance, and when you go to an acrylic painting, they can reach, for instance, 150, 200 lux. That is how many light, so not the quality, but how many, the quantity of light. And here we are. This is an example of a project. Do you know this masterpiece? Nobody? This is a piece of art by Andy Warhol. It's called 60 Last Suppers. That means that is the Last Supper repeated 60 times. 6 times in vertical and 10 times in the horizontal axis. The picture that I'm showing you now are shot by the professional photographer of the Gagosian Gallery that gave the painting to the Museo del Novecento here in Milan, in Piazza Duomo. The architects that worked on this exhibition is CLS Architecture. Is one of the most famous architects, first in Milan, and we were technical partners of this exhibition. So you see, here light was just a part of the exhibition, because one of the most critical parts was the concept itself from the architects. When talking about lighting a painting, usually we have to respect a few formulas. For instance, the direction of light, the degrees, and so on. So we have a few preferred positions where to put the luminaires, but that was not the case. The problem of this installation was that we had to respect the concept of the architects, because they wanted to put the painting in that position. So with the back of the painting directed to the windows, so that the visitor could see the painting, but also Piazza Duomo on the background. That was a beautiful concept, but very critical to light this masterpiece. You see this beautiful view, and at night as well, with a cold cathode, that is a piece of art by Fontana on the top of the room. And why this was critical? Because this was the position that we had to use to put the luminaires, and we couldn't move in one direction or in another one. That was the position. And usually when you read specific lighting manuals, you see that there is an angle that you have to respect, not to have glare in your eye looking at the painting. And this critical angle is usually 35 degrees. This is exactly 45. So the perfect angle to have glare. And that was very critical, and we had to discuss the concept with the architects in order to maintain their philosophy for this concept, but also to have a perfect illumination for the painting. You see there the projector that we used is an LED projector, so with all the characteristics that we were talking about before, with a color temperature of 3000 kelvins, with a CRI that is above 90, dimmable because you have to respect the painting, that is an acrylic, so not to go ahead of a limit of average illuminance. And we also used accessories like honeycombs, that is a sort of filter that you put on the head of the luminaire just to reduce the glare. So this was the first solution that we found to reduce this kind of glare. This is a technical section of the installation. You see a three-phase track with 12 projectors with a medium aperture, 28 degrees, pointed exactly with that angle. You see the blue line that is going directed to the painting, and then it bounces down with the red line on the floor. That means that, look at the head of the observer, that means that the observer is exactly inside the corner of glare looking at the painting. So that was the critical part of this solution. So first, we had to discuss with the architect to find a solution to respect their concept, to have the painting with the back to Piazza Duomo, to maintain their concept. And the solution was to dim down the luminaires, to put filters on them, and to avoid putting a protection glass on the painting. Because with a protection glass, you have the reflections. So, in the end, these were the calculations. You see, this is a simulation with a specific software that we use every day for lighting simulation. You see that with these lighting calculations, we defined a dimming value of the 30%, so very low, to maintain an average. You see the green and the yellow values on the painting. So not to overcome these values, we had this need to dim down all the luminaires. We have an average of 134, so I was telling you before not to go over the 150, so we did it. But another thing that is very important is uniformity, because you have such a great and impressive painting in terms of dimensions. 10 meters by 9 meters and a half by 3 meters and a half, so very huge. And so you need to avoid to have different areas in terms of lighting. So you need a very good uniformity, and in this case is 0.5, 0.6 is a very good uniformity usually. And as I told you before, we used projectors with 3000 kelvins and CRI more than 90. This is a picture from the above, and you see that the luminaires are directed to the painting, and there is no protection glass. This was critical, and this was the solution to avoid glare. And what happened? That we have two bodyguards for the painting, 24 hours a day, in order to avoid to put a protection glass on it. This is another angle of the solution. You see that the projectors in angular positions, and this is the result at night. So you see the cold cathode on the top, you see the dwell on the back. People can also pass through the back of the painting and the windows, because there is a path behind the back of the structure that is sustaining the painting, and you have no glare. Of course, when talking about color rendering, it's a bit funny because this is a painting that is white and black. So which color temperature you have to choose? Cold one, a warmer one, 3000 Kelvin, 4000. It depends not only on the colors of the painting you have to light up, but also on the atmosphere, on the personality that you want to give to the setting of the lighting. So a colder light just to see every detail, but probably a bit too technical. A warmer one just to create also a mood inside the space. And here you see again a perspective with not only the painting but also the solution, because you see the luminaires, you see the painting, the distance, and another important thing probably for you is not only the exhibition itself, not only the lighting that we used to illuminate this painting, but Gisela told me that you are going to work on a black light exhibition, and you are also going to study the graphics of the event, and so look at the colophon with all the description of the painting on that corner. That is describing exactly. Let's see if I can find a better image. And that was another element that we had to point with axle lighting, to add another projector just to have a spotlight directed on the colophon with all the description and so on. So I hope I was quick enough. And there are any questions? So I just tried to keep it simple. I just tried to keep it quick. ha un suo router wifi, un'app di comando su iPhone, iPad, e tramite questa applicazione, l'infrastruttura della rete wireless che è già presente, è possibile comandare i proiettori singolarmente o in gruppo come slide all'interno del binario, come rotazione, quindi come puntamento, e come intensità luminosa. Questa è un'applicazione convenzionale, può essere in un museo dove abbiamo la necessità di puntare proiettori con tutte le caratteristiche che abbiamo visto prima, ottiche, resa cromatica molto alta e così via, ma ogni volta che cambia l'installazione temporanea, i proiettori bisogna prendere la scala, andare su, modificare tutti i puntamenti. Questo è quello che offre la tecnica oggi, cioè la possibilità, per esempio in un museo, al cambiare delle installazioni temporanee, al cambiare della mostra, i proiettori effettuano uno slide all'interno del binario, si spostano, vengono puntati, un ristorante che cambia da un setting aperitivo a un setting cena. Avevate già visto una cosa di questo tipo?
L'ho visto a Salone.
A Salone, benissimo, è proprio questo. Siamo, se puoi, al video successivo. Questo era un po' più schematico, adesso vediamo un video un po' più concreto. Questo è l'esempio di una vetrina in un utilizzo convenzionale, cioè trabattello, scala, puntamento manuale di proiettori. Questo invece è quello che è possibile fare oggi con la tecnologia. Avete visto nella presentazione prima della mia tutte delle scenografie interattive con le persone. Ecco, questo per stare in un ambito non di arte, non di chiaramente un ambito professionale, quello che oggi con la tecnologia Bluetooth e wireless è possibile fare.
Logicamente tenete anche in considerazione le estetiche maritime, tipo
Certo.
i verticali vetrine non sono mai così pulite.
Sì, questi sono tanti esempi che si ripetono nelle varie casistiche. Chiaramente questa applicazione è molto difficile perché significa spostare tutti i tavoli, andare in altezza, mettere tutti i faretti, mentre invece una cosa di questo tipo si avvicina un po' di più allo show, nel senso che questi apparecchi sono molto presenti nel lighting per lo show, quindi Hollywood, premiazioni, spettacoli, però solitamente sono delle teste robotiche, quindi degli apparecchi che sono molto grandi in termini di dimensioni. Non sono degli apparecchi architetturali disegnati molto puliti, compatti, come tende a fare Frost. Voi vedete sono dei piccoli cilindretti di 15 cm. Questo è un caso piccolo di un'esibizione museale. Ecco, questo così per farvi vedere un esempio di quello che oggi la tecnica può